So for question number 10 part A, it tells us to write the whole equation, this equation, as sec theta. So we know sine theta, then root over cos x squared theta minus 1. We know we can write cos x squared theta minus 1 as cot squared theta plus 1 by, it's given root over 1 plus tan squared theta. We can write it as sec squared theta. The next step is to write sine theta by cot theta plus 1 by sec theta. So the next step is to write it as sine theta tan theta plus cos theta. So what we can do is write this part as sine theta into sine theta plus cos theta and then plus cos theta. The next step is to just carry out an LCM. We end up with cos theta and then sine squared theta plus cos squared theta, which is eventually 1. So we get 1 by cos theta, 1 by cos theta, which is sec theta. Thus proven. So for part B, it tells us sec x is equals to alpha, where 3 pi by 2, so there's this range of values of x is given. They told us to find sine x in terms of alpha. So since sec x is equals to alpha, we can write cos x is equals to 1 by alpha. We know sine square x plus cos square x is equals to 1. So sorry, my bad, there will be a correction here. We need to write this as cos x. This will be cos x. So sine square x plus we can write it as 1 by alpha square equals to 1. So what we will do is sine square x is equals to 1 minus 1 by alpha square. So the next step is to write sine x is equals to plus minus root over 1 minus 1 by alpha square. Now the value that was given here was 3 pi by 2. X is greater than 3 pi by 2, x is lesser than equal to pi. So in that sense, the only acceptable answer will be sine x is equals to minus root over 1 minus 1 by alpha square. That's your answer for question 10 part B.